going to round off our answers. You will in all science and engineering classes as well. And when we round them off, it's not because we don't want to write all of the digits. It's because some of those digits don't count. Some of those digits are not actually known due to error in the number. So if a number has been rounded off, that means that it is an inexact number. Where we really don't know all the digits that would be there. These are anything that has been estimated. Anything that is measured with an instrument is never measured exactly. If you measure out 10 milliliters of water, you're never going to get 10.00000 and so on milliliters of water. So measurements are never exact. Anything that is a constant that has been rounded off, like pi is often rounded off to 3 digits, those are not exact. And then anytime you do a calculation using these inexact numbers, your calculation results in a number that is also not exact. And we will have to decide where we should round off that number as far as how many digits do we really know and how many are just there because our calculator gave them to us. So there are numbers that don't have any error. We're going to call these just exact numbers. Exact numbers, you need to know which ones are exact because they do not affect the error in your final answers. And we'll be calling this, when we are deciding where to round off our answers, we will look at the ones that are exact and ignore them because they don't contribute to the error. Anyway, there are two types. Some are exact by definition. In other words, if we've defined a minute as being 60 seconds, then those numbers, both the 60 seconds and the 1 implied minute, those are exact. Also, anytime you're counting something, those are exact numbers as well. Okay, so let's talk about the measured numbers that are not exact, inexact numbers. When we write down a measurement in the lab, or if a problem gives you a number that is a measured number, the way that the number is written tells you the value, but it also tells you how well the value is known. So in other words, if we write down the number with these extra zeros, then that means that we have a lot of precision with that measurement. So this measurement would have less error than this one. When we write down the numbers, we write down all the numbers known with certainty, all the digits known with certainty, plus we're allowed to estimate one. So for example, on doing this measurement here, I know some digits with certainty. I know for sure that the length is between the 9 and the 10 because there's a line for 9 and there's a line for 10. So I know I'm going to write down the 9. I know that with certainty. The next digit, the 0.1, there is a line for 0.1 and a line for 0.2, and I can see with certainty that the next digit I need to write down is a 1. Now when I go to write this next digit, I'm going to have to estimate. I'm estimating between those two lines, the 0.1 line and the 0.2 line, and this is the digit that's going to have some error. Okay, so when you write down a measurement using a measuring instrument that has lines, you write down every digit that you know with certainty because there's a line for those, and then you estimate one digit that is between the lines. Okay, and so this is, it doesn't make sense to write another digit after that because I have no idea. I mean, this one was the estimate. You're allowed to only estimate one.